So we've got a roll cage tacked into position, and that's our foundation for the rest of the cage. It also might be the easy part, because now we got to figure out how to stick all these tubes together. And that's where the ends come into the picture. Dang it. Now there's a number of ways that you can notch the end of a tube to make it fit tightly up against the other tube in the intersection. It could be as simple as taking a 4 1/4 inch grinder, putting a cutoff wheel on it, cutting 2 angles that are appropriate for the transition that you're making. Obviously, if you got a 90-degree angle, it's going to be a 45 on each side. If you're going to be intersecting at an angle like that, one side is going to have to be more shallow than the other. But bottom line is, when you get done doing that, you take a grinding wheel and you touch it up and you end up with something like this. And that's the technique that I used to make this, because I was kind of in a hurry. But what you need as a beginner is something that is going to give you good repeatable results that work every time. If you use this technique as a beginner, it takes some time to master, and you're going to end up with a lot of smaller pieces that can be used for much smaller projects. So that's where the Bailey Industrial tool comes in. The Bailey Industrial Notcher is a tool that enables you to put perfect fish mouths on the end of your tubes every time. This tool costs about $250, and it consists of a frame, which is made out of 6061 aluminum. It has a block here with a couple of needle bearings that this arbor runs in. And on the end of the arbor, we have a threaded nub that a hole saw fits on. The hole saw is going to be the same diameter as the tube you're going to cut. And in this case, our tube is 1 3/4. That's the size of the hole saw. So what we're going to do is we're going to use a 1/2 inch variable speed drill in order to drive this. And we're going to clamp this in a vise. Now it comes in a bracket that enables you to mount it vertically, like in a drill press or in a vertical mill. But they recommend that you use it horizontally, but there's really no way to clamp it in a vise. And so what I did is I took this piece of, I believe it's 1 3/4 by 1 3/4 square aluminum billet, and bolted it on, and that enables us to clamp it in a vise. Now you can see right here that we've got a C-clamp, which we use to hold the material. Like this, we put it in the tool in this manner, and then we use the hole saw to cut the fish mouth on the end. And the tube extends to roughly the middle of the hole saw. So let's see how this thing works. We have our material firmly locked in place. We've got our 1/2 inch dry variable speed drill in place, and what we're going to be doing is we're going to be hunting for a speed where the saw really likes to cut well but not generate a lot of sparks and that sort of thing. And there we go. We have a perfectly shaped fish mouth, except for one thing. It's off center. Now the Bailey Notcher works really, really well putting notches on the end of straight pipe. But what if you've got a bend that you have to put a notch in? Well, that's a problem. The Bailey Notcher isn't going to do that. There are some that will, but they're pretty expensive. And being that you're building your own roll cage, you got other ways that you need to spend your money. So what are you going to do? Well, there's a technique here that I've used for quite a while, done many, many times, that works really well. And we'll show you the concept, and then we'll demonstrate how it's done with the A-pillar bar that we're putting in the Champ car. This technique is pretty simple. First of all, you need to make a scale drawing of what you're going to be doing. And what we got here is a situation where we have a tube like this that's vertical that we're going to have a tube like this plug into the side of. So what we need to do is notch this tube somewhere up here in this bend. Now this would be like in the situation where you have NASCAR style door bars, although the bend would be a little tighter and so forth, but you're going to have the same exact thing down on the other end. So you're going to want to make a drawing of the entire setup. I'm just going to use this end to illustrate the point. So what do? Well, after we've made the scale drawing, what we do is we lay our bend on top of it, and where the bend begins, that's where this line is right here. And the way that I laid out this line here is I just simply took an O-ring that fit fairly loosely on there and put it in place and just took a paint pen and followed it around. Okay, the next thing we need to do is we need to draw this line right here out beyond where the notch is going to be. So I'm going to place this in position, and then I'm going to locate the very top of it, which eyeballing it is right about there, and then just sort of placing your knuckles, riding your knuckles along the tube and holding the paint pen. That's a pretty good line right there. Okay, the next thing we need to do is measure the distance from here to the edge of the tube that's going to be going up, and that's 3 7/16. I'd almost call that 3.5. 3 7/16. So we're going to take this tube and we're going to lay out a point 3 7/16 right there from that line, which is the beginning of the bend. By the way you can tell that that is the beginning of the bend, take a straight edge, hold it along the back side. Wherever you start to see daylight between the straight edge and the tube, that's the beginning of your bend. Okay, so we know now that this notch is, the edge of it is that far from that line right there. Now what we can do is take a piece of tubing that has a notch cut on it, like old Nemo here, and just lay it on top like this. And what we will do now is we'll just make a mark like that and make a mark like that. And if we look at this, we can see that that's pretty much a straight cut. If I take a 4.5-inch grinder with a cutoff wheel and cut along that line right there, that's going to be one side of my notch. What I'm going to do then is go to this side, make the same line here, measure 3 7/16, which is right there, and take our little guy and do the same thing there and there. And there we are. Do that on both sides. And you can see that if we just take a cut through here and a cut through there, that's going to get us started as far as our notch is concerned. And I can tell you, through using this many, many times, this works great. You just have to be as accurate as you can be, understanding that you're going to be using a grinder to fine tune this, and that gives you a certain amount of flexibility. Assuming it's not too short. That would be a problem. Then you got to come up with another solution. But trust me, that works really well. And what you're going to be doing eventually is you're going to be rounding this like that. Same thing on the other side like this. And that'll work. That's going to be really, really good. All right. Now how we do the rest of it, we'll demonstrate. So we've got a preliminary cut made, and we can see that we've got a problem in terms of fitment here. It's quite loose. This 90-degree cut that we made would be the correct cut if we had two tubes that were of infinitely thin wall thickness, and they just smoothly transition from one to the other. But the problem is that we have material here that's 90 thousandths of an inch thick. So what we got to do is we got to shape the inside edge in order to conform to this surface. We're also going to have to take and round these points. Pretty close at this point. I'm going to keep on trimming, and I'll let you take a look when we're done. After about 5 minutes of grinding, you can see that I have a fish mouth that generally conforms to the lines that I laid out, maybe just a little bit further back than I would like. This side's fine. And you can see that we've got ourselves a pretty good fish mouth right there. That's going to make a good weld. So what remains at this point is to see if it actually fits in the car. And that's how it looks, folks, all the way around. Perfect fit. At this point, we've begun the process of welding up the roll cage. The thing you want to do at this point is to weld everything you can get at when you've got the structure tacked to the chassis of the vehicle, so that you don't get a lot of warping and bending as you're doing this. The issue, however, is going to be that there are some welds you're not going to be able to get to all of. For example, up at the top here, the middle bar and the A-pillar bars where they attach to the cross tube, as well as where the A-pillar tube attaches to the main hoop. You're going to be able to get to about 80% of those. Somehow you're going to have to get the rest of it done, because all sanctioning bodies are going to require that you have 360 degrees of good quality weld. What we've done is built rocker boxes and rocker plates that actually weld to the rockers of the vehicle. Underneath the rocker plates, which I bent up to look like that, underneath the rocker plates there's holes in the rockers so that you can drop the roll cage down into the rocker, and when you get your welding done, put the rocker plate back on, weld it in, and perfectly good structurally. Back here though, I had to put the main hoop, make it a little bit smaller so that it fit down inside of the rockers, because I needed to install the X bars here, and they interfered a great deal with the B-pillar. And in fact, you can see I've relieved the B-pillar quite a bit here, even having done that, particularly on the driver's side, because the X bar has to go out away from the driver. And instead of just plates, what I had to do is to build a structure that looks something like this, probably a bit more than it really needs to be, but that's how it turned out. And what this does, once you get these 4 pieces removed, it allows the whole cage to drop down, and you can easily get to the top of each one of these intersections and get your welding done. Lift it back up again, put the rocker boxes and the plates back in, position your cage, and finish it up. We'll give you an opportunity to see what it looks like when we get the plates out here in a little bit. And here's the roll cage dropped down into the pockets and also the inside of the rocker panels. And as you can see, we have complete free access to the welds. Jack it back up again and get on with the rest of the job. I try to make each tube do as much as it possibly can. For example, we used the transverse member on the main hoop to hold the seat support. Also, the transverse member up here in the front of the cage we use to mount the steering column. And we got a couple of tabs that are welded to the front side of that. And in order to adjust the angle, all we got to do is come up with the right size bushings. And we've had all the drivers sit in the car, and that's going to work in terms of steering wheel position for all of them. Okay, another thing that tube is going to do is it will hold the electronics panel with these special brackets that I fabricated that clamp onto the tube, and also the instrument panel is held on with the same kind of brackets, just different. It's a real clean design, I like it. Champ car requires a seat back support so that in the event of an accident, not only is the seat secured to the bottom of the vehicle, but also it is secured fore and aft by some sort of a brace. And we can see that in this particular case, we've got probably about an 8 or 9 inch piece of 1 1/4 inch, I believe 14 gauge steel tube with a number of holes drilled in it. And we've got a 4 inch long piece of 1 1/2 inch, 11 gauge steel tube, and they fit one inside of the other very, very easily. Works great for what we're doing here, and that's got 1 hole in it. The point of that 1 hole, of course, or the point of all these holes, is so that when the driver gets in, we can pull the seat up into the position that we need, and then we can insert a pin through the holes, and that secures the back. Now you'll notice that there's a couple of bolts in here. These serve as pivots because there's a little bit of an angle here. There wasn't a real good way to do this any other way, so as the seat moves, you can see that it changes its angle a little bit. So in that way, we've got these 2 bolts which serve as pivot points to enable this mechanism to rotate up and down. And what we'll use is a pin with a cotter pin, or perhaps one of those ball detent T-shaped pins that would work slick to secure that. Be very easy and quick to adjust the seat when a new driver gets in. I think that's going to work great. Someday when my welding mojo shows up, I'm going to finish welding it in up here, and these tabs to the bracket on the back of the seat, and for all practical purposes, at that point, the roll cage will be complete. Well, that's all I've got. It wasn't intended to be an all-inclusive tutorial on roll cage design and construction, but I think it's enough where you can at least know the right questions to ask and speak in an educated manner when you and the guy who's doing your bending, or you and the guy at tech inspection, get in a conversation about why you're doing what you're doing. or why you did what you did. So if you like these videos, like us, subscribe, follow us on social media, and leave a comment down below so that we can know what we can do to do what we do better. So we'll see you the next time on the Camp Chaos Chronicles.